Okay, on this worky preamble, we're going to turn away from linear Haskell, which I'm not likely to use in this project anyway. So, good evening. So I don't know if you noticed. Move away. I don't know if you noticed, but there's something off about this. I realized that when I turned the program on earlier, like when I set up the stream, I realized something. I don't know if you noticed that, but there's some weird annotations here. Printed theorem, started theorem, and things like this. It seems that when we removed the debugging code the other day, we removed any occurrence of debug trace, but in at least two places I had apparently used printf instead, or put strlen. So if any doubt that we were tired yesterday, here we go. So we're going to remove these two lines. I think that's all. This one is on purpose. I'm pretty sure. This looks much better. Fix, remove, debug statement. Okay. We've already achieved something today. Anywho, I also wanted to make two additional notes to the totality thing. So in NuPerl, there is a statement, there is a judgment, which you can reason about corresponding to reduction. But I'd really like to not have to talk about reduction. So in NuPerl, there's this thing like you have U reduces in one step to V. With one, you can define U reduces in many steps to V, and then you can define U converges or doesn't based on this reduction relation. But I think it's somewhat too sophisticated. I'd like to do that. I like to avoid verifying reduction and only talk about equality. So I've got a hypothesis about totality at nat. And this hypothesis is that we may be able to define total natural numbers as natural numbers for which induction holds. I think it's also sort of familiar with a NuPerl approach where, I don't know if you're aware of this, but in NuPerl, they have built-in, or like sort of, they can define it using, I don't remember exactly, but at any rate, they first define co-inductive types, which, and I'm saying this on camera, on the record, should absolutely be called projective types. But for some reason, people didn't think about that when they named them. So we kind of stuck with co-inductive for the time being, until a revolution happened or something. So they have this co-inductive types defined, and out of co-inductive type, they carve out the inductive part. I think you might need the existence of natural numbers to do this. I don't remember exactly how the construction goes. Here it's not really the same issue So we have termination and non-termination, basically. It's not about infinite structure in as much as we have things that can do nonsense. And we want to be able to explain that it's not doing nonsense. But so I'm thinking about this, like saying, okay, a total natural number is a natural number such that, like, let's write that. The idea would be something like a total natural number is an element, like a term that will be n, a term, we'll call it n. Let's call it u because n sounds like a number. So that if for all p, something we will start to be able to talk about today, of type yeah, what this type exactly is a good question. P of 0 and P of n and for all n P of n implies, I should start using these notations. I think implication is, whoa, something weird has happened. No. Oh, it seems like my nodes are in the middle of my main function. That's hilarious. Okay, so this one, what did I do this time? So the main issue when you're tired is like lack of precision. That reminds me of a maths professor who said that the non-Archimedean domains were named after an ancient Greek mathematician called non-Archimedes. I am very fond of this. I don't know how the present conversation reminded you of this, but I like it a lot, either way. So something like this. I'm not saying that it makes perfect sense, but I'm thinking that maybe something around this would let us define totality at n in a satisfactory way. Co-projective types. I'm sure you're aware that a co-mathematician is a machine to transform co-theorems into phi. Mathematics are fun. Okay, so that was the random thing I wanted to write. It's just as much for you guys as for me. If I don't write them down, first I may forget them, and second I can't stop thinking about them. If I write something down, it's there, it's sort of frozen, and I can take it out of my brain. And that is good. So what we want to do is, so we want to be able to express this sort of things to quantify over prepositions. But to be able to do this, because we can only quantify over terms, we need prepositions to be term. Contrary to like dependent type theory, we don't want prepositions to be. We don't want prepositions to be types. So prop is not a kind, so to speak. We really want prepositions just to be terms. Yeah, they're not typed. They're not inhabited. We can. There's some types that correspond to prepositions, but really sort of in their essence, prepositions are just elements or truth value. We can call them truth value. Some people don't really like to call them prepositions because preposition is all about the syntax and it's quotiented by equivalence. So you can call them truth value. They're the global section or all the sections in general of omega in some typos. So they're element and proofs of a proposition are a somewhat external element. That's sort of what we want to get so that we have no trouble with subtypes and quotients and so on and so forth. And then based on that, we can build more things. We can build some type theory if we want, but the basic thing has proof irrelevance baked in because proofs are not objects of my term syntax. I know it has advantages and costs, so I just want to explore it in this particular way. So right now, prepositions are completely distinctive syntax categories. So go to this syntax definition. So I've got this type prop of prepositions here, and I have the terms here, which are very poor. So the goal is to merge these two things into one. But before we get to do this in the grammar, we have an abstract syntax, and we should start with the abstract syntax. So where are we? Here. So I'm going to move prop up, which should not affect compilation. Great. Speaking of which, there's template Haskell in this file, so moving things about has the capability of compromising compilation. That's because so to run template Haskell, you need the compiled version of something. And so the way this is done is, well, you can always have the compiled version of another module, but sometimes you want to talk about things that you've defined inside this module. And so what JC does as a heuristic is just like to slice the module up into like runs. And in a run, there is no template Haskell. And then there's a bit of template Haskell, and then there's a new run. And in a bit of template Haskell, whatever you can do is whatever's the top of this. You compile the run from top to bottom. Whereas in a normal Haskell file, everything is mutually recursive by default, with all the pros and cons that this has. But it certainly gives a lot of liberty to express things in an order that is more convenient for pedagogy, for communicating your code. Not that Haskell people take advantage of this. Most of the time it's just random order anyway. But anyway, I'm rambling. So what I want to do is this here. This is going to be a long haul now. And we're going to do this so that we have a type of prepositions, and we can replace things that matter first and then deal with eliminating the word prop. I didn't expect that at all. That's actually okay. So what am I? I'm surprised because there is zero type error. It's not entirely surprising. Going to merge two types. Things continue type check, I suppose. And what we only have is pattern matching. Incomplete pattern matching things, which we should So let's go forward. Extern term. Okay, this one will have to stay like this for a while. Term subs. Okay. This one cannot stay that way. Now we're gonna have type errors. Now we will have types in terms. So we have to add these. Oh, I don't have normally running. Never mind. I'll deal with that later. Now we need an extra one of these here. Go on R type, so it's quite this way. I don't need this one actually here. There's a type error down below. That's because I also need an R type to R type. Yeah, this is going to be annoying. Just going through this and fixing that will be annoying. So here we need on R type, and we need to pass it here similarly. Interesting. Okay, so of course, right here we need another type version of this. It's so warm in here. I'm already burning. Anyway, how's the weather where you are? Here, it's about 30 degrees. It was not very bright, the sun, I mean, today. So, could have been worse. But it certainly warms the inside of one's home quite a bit. Okay. So I need R type to R type. I don't know where the function is, but it has to exit. Oh, it's over there. Oops. This one might not exist. I'll see. It does. Fantastic. Okay. We're back at... Let me, okay. I'm a bit paranoid these days. Hey, Chungor. You made a Twitch account so that you can complain about weather in London. Sounds like you're perfectly integrated. Sounds like the most Londoner thing to do. How are you doing? So, let's start from the very top. So what do we have here? Yeah, I said not quite the very top, because these ones are not very interesting. Okay, now we have all the arguments about term stubs that we will need. So we can merge with propositions. So I'm going to copy all this first. We can remove onProp everywhere. See, it's written in two different fashions. So onProp space with nothing up. And onProp without an underscore with nothing as well. Ah, not quite. Okay. Yes, no, yes, no, yes, and no. Okay, and the remaining onProp will be replaced with onTerm, because, of course, substituting on props and terms will be the same thing. Oops. What with onTerm? Yeah, shoot. The easiest is that one. Okay. Now I've got an error somewhere. There's several definitions of prop subs because that should be term subs. Interesting. Okay, so we are back with incomplete pattern matching, but not here, expectingly. We are going to kill this. So, and the way we're going to do this is to say that okay, I'm not where I thought I would be. Okay. I'm going to take it slow tonight. One thing at a time. Equal term subs on term on R type. We're just going to ignore the last argument. We'll remove it later. To uTerm. That is more interesting. So I've got to go and edit term view now. This all is entirely a game to see how long I manage to avoid defining terms as the fixed point of term view, basically. I'm resisting this because it's full of annoyances, but it's really the right way to go, though. I need my term thing. So let me pull here the definition of terms. So actually, I think the easiest way is just to copy all of this, Place everything here, like the P's by V, most of them. Okay, so this is fine to decompose. This is AA, this is AA, and this isn't. Because the proposition here is in a different context, and I'm going to just assume that for now we're going to consider for all as atomic, because I don't really have a way to talk about open terms, incongruence closure, or in unification, and so on and so forth. It's complicated. I forgot one of them. This is also going to be very entertaining. Can't find ORD. Because it need a Nord on prop, I guess, and a show on prop, which is term. So I guess I just need to derive it over here. Ord show doesn't manage to. I need to show annotations and okay, and Ord annotations. Okay, so that's not too hard. That would be compare, right? Compare is an ordering, and ordering is EQ all capital, I'm pretty sure. So eq like this. Okay. I need a node for R type as well. Yes. Okay. It's for the greater good. And I'm going to break equality for show because it don't matter. So show an A equals show A. Guess a new type, so we could derive that. New type deriving. Whatever. R type deriving EQ Ord show okay, that went fine. Phew. All thanks to the power of De Bruyne indices. So where were we? Oh yeah. Right. So we can close this window here. I don't want to kill the buffer. Sorry. I want us to remove the window. I think is the name in Emacs. And now I have to make this pattern exhaustive. Maybe I shouldn't have closed the window really. I'm going to need this again because who would imagine I have like memory or anything like this? Okay. I miss things like Agda or Merlin in a camel way of just splitting the term, giving me all the prototype. So okay, so we don't need anything here. This is most amusing. Equal U and V. We'll need a substitution for this, I suppose, or not. We never need a substitution. Fair enough. Except for variables. So to U term, V equal to U. Oh yeah, I need a substitution here because I need it for the recursive call. To U term subst U to U term subst V. Notice this all that could be done for free. B equal is not in scope because it's V equals. Better. Then we have P naught. Okay. Equals with impl, and last but not least, I am friend with beneficiaries. An interesting kind of friends. How are you doing? For all x, to p equals. I copied all this, but I need none of this. Because it's just the same thing with a V. Oops. Define but not used to U term because I want it to be capitalized here. Nice. Well, good luck with this adventure game of yours. This is my text-based adventure. And I really don't know where I'm going with this. So, more of this. Well, not today. And not for a while, actually, because I'm going to be quite a bit offline. But if you come next time around, I do a stream like this. And give me a link. Or just like whisper me a link and I may have a look later. So, but I mean, like, not within a week of now. So, sorry, I lost my track now. Oh, we need to do the same thing again. Oh, that's fantastic. So this could be that other thing from p2 down. Okay. We're gonna have to align everything. Oops. We're going to replace to U-term. It's not going to be faster than doing it manually. It's just less annoying. To U-term subst with view as well. Yeah, we're not going to need the recursive calls, but it's fine. We can also move everything in a line like this. Oops. I think I'm pressing random buttons. Okay. I can remove unification.uterm nothing. Poom. I can remove this. UV. U. UV. UV. Okay. More. Oh. I think oh, it's interesting. It's not the next. That's very funny. Okay. I love how it's sending me in random places. Okay, here I don't need the other one because we're just going to merge type infer intrinsic term and type infer. Oh, we don't have intrinsic prop. Oops. So I'm wrong. But maybe I just don't use that, right? So maybe. Maybe I don't really need these. Ah, I do. Is that just test for them? No, right now I use them. Okay. So I said something for the second time, and I was wrong about it for the second time. So let's open up this window again and go back to my term definition. We have all these that we need to type check or to infer the type of. Yeah, actually, it's either to infer the type or to type check. I need to figure that out for each of them. For true and false and equals, I guess, let's check something. Type infer prop. No, I didn't do it because I only have type checking for prop. Yeah, we're only type checking things. But on root of this, we also do some type inference of terms. I guess the main mode for propositions is type checking, though we can infer it, I suppose. Yeah, well, let's just try to infer it. But let's see how it goes by doing as much inference as we can. So, type infer intrinsic term, and we don't need the environment. P2 equal we need something. Do return something. All as haddock. Okay, so I need a type. So I need to add a type to my iTypes. Let's go there. Data, iType, here they are. We need a new type for prepositions. Let's go with iProp. And now, here, I can put iProp. Could also use a slice like this, but yeah, whatever. Okay. I would love all patterns. And now we're getting into more interesting things. Actually, this is fairly easy. Term and p equals u and v. So we're going to start with a do, and we're going to have to infer the type of the first term and check the time with the second one. It's completely arbitrary. We can do this. So how do I call things when there are several of these? Let's have a look. So it's pretty much here. Show. I'm gonna do let just iType of you I guess I can just sort of copy this, right? Well, not really. Okay, then never mind. Equals type infer intrinsic term and view. And then well, copying is not that bad. Whatever. Right. So we type check, and when we're done, we can it's interesting. There's no monad here, you know. We can return I'm not sure this is checking anything. I'll fix later. Actually, we have maybe monad, so maybe we can just do this. This is forces some return something here. No, yeah, okay. Here we should have a whole, and it's of type B. So it's iprop anyway. So we know it's a proposition. We can infer that type. There's no problem. Say what? That is very unexpected. What did I do? Whatever happened here? What? What? Like, I could ignore it, but I just want to figure out what happened. This is ridiculous. What did I do? Yeah. There's not Runken type, but there's scope type variables in there. Yeah. Sure. I have no idea. So in that case, P0 is fairly easy to do as well. So we know P0 is a position here. So here, what we're going to do is we're going to do a case like this. And not with I type of view because it doesn't exist, but with iprop. And I forgot the unit 2. And that is P. This fixed itself. I wanted to be I wanted to see if something was there before I saved again. That was so weird. I noticed that my conversion from bool to prop is a bit repetitive, so we're going to abstract it someday. But right now, can't be bothered. So we're type checking P and we're type checking Q. Both need to be prepositions, and I return a preposition. Well, the type preposition. Look, it was not a problem. There was a bug 1,000 lines away to where I had edited pertaining to something that I had not changed. So most obviously some weird state was received by GXCI and didn't properly reload, or I don't know. It was obviously a fluke, something. I mean, you just needed to save again and that would not work. Like maybe I saved twice and it sort of read the file. I have no idea. I wanted to figure it out, but honestly, I have no idea. I checked the entire diff just to see if there was something. Oops, there's no or, but there's an impl. That could be the matter. And for all, I wrote inter Damn it. Env p funnel, can ignore the annotation. Type and prop p equal what's the type of my environment? I type env I push db to equals over db to call it hash db. That is fair. So what I want to do is type check p like this. It needs to be a prop, but the environment push I push db of underlying I type of toe and I want to return iProp. Okay. This function is most useless, by the way. So we just wasted a bunch of time, but I couldn't figure out how to get rid of it for the time being. So now that we compile again, more T. Ooh. Okay, let's continue working down this file. Let's look up for first. Embed itype. Okay. That's a good point. So we can fix this by going to data rtype and adding an r prop here. In here, in here, oops, that was the same one. Okay. Why is this one happy? Not exhaustive. Oh, because I need to do rprop as well. There's a lot, like we're doing like 90% boilerplate, which is a bit annoying. but it's not boilerplate that is easy to abstract away. So I know not. Good. Constraint. Type infer refinement type. We're finally getting somewhere. Whew. Well, that was long. So here again, we are checking things, but we probably want to infer them because it's completely obvious that conjunction will be a preposition. So there's no real reason not to infer it. Though I must confess that there is probably not a particular reason why one would want the preposition somewhere where it's not expected, but I don't see a reason not to put them here. So type check preposition with type infer refinement type. Refinement term, sorry. I was probably not going to type check out right at the bottom. Yeah. Good match unit with our type. Yeah. That was surprisingly easy. Now type check preposition tells me, oh, this is not exhaustive, but I don't care because I think it's the same type as that one. And oh yeah, I need an extra argument. Yeah, of course. So I'm gonna remove all this because we've moved that over there. We want to type check that P is a preposition. What we do is type check refinement term and P at type R prop. Okay. That'd be good. No more flight check errors. More flight check errors. I lost P true and P false for some reason. Not that it's really hard. Oh, that's funny. So we're undoing some things we've done before, but not all of them. So this one, yes. Oh, yes, no. Yes, yes, no, yes. This is very, very, very small. We're almost there. There's a special whip. Aha. Yes, that is true. That will be even smaller now. Extern, extern, extern. Ha. Well, we can't fix extern until we mix the thing. Grammar. So we need syntax for preposition. What should I do? Should I write it prop? Is there a better Unicode symbol that would symbolize prop, or should I call it capital Omega to make it very topicey? I'm thinking the word topicey should be a more common word. I'm going to start using it. So chat, any suggestion for the name for the prop type in the syntax? Again, I want to look at the mathematics symbol group, but it's not. It doesn't really have many of these. Nabla would make a terrible name for preposition. Like right around the math blog, there are some very cute things like a wristwatch. Oh, there's the benzene ring. It has nothing to do with mathematics whatsoever. But I need to find an excuse to put it. Subobject classifier. Sure. What is this? Benzene ring with circle. Okay. APL functional symbol omega underbar. Like, Unicode is fantastic. Here are random symbols that I found. You can't really see them very well. So I'm gonna increase the font size more. So this is the benzene ring, and this is the ring, the circle version of the benzene ring, and this is the APL symbol omega underbar. Why did APL need an omega underbar symbol? I mean, like, you should just think about it. How much had to be invented? How fantastic! Like, how crazy was everything? How new and exciting was everything for someone to say, "Hey, let's make a programming language where one of the symbol is omega underbar." It's crazy. It's fantastic. Just imagine what it would have been to be around, like at IBM, where people invented omega underbar. Here's another APL symbol. This one is called Functional Symbols Circles Type. It looks a bit less crazy somehow, but still. And the fact that someone thought that it was really important for Unicode to have all of APL symbol. Fantastic. How about that for a proposition symbol? It's the king from chess. It's gonna end up being prop. We all know this. I don't know what else it could be, really. Yeah, I think they just had keyboards for all the symbols. I think so. Like it was a several level keyboard, and you had the normal letters on level 1 and 2, and then you had, and all the letters would double as 1 or 2 symbols. Like we should find some, but I can't see the omega underbar on this one. So maybe there was some combining symbols. Like there's, if you look at this one, there's over the 2 there's an underbar, or maybe it's an overbar, and here is an omega. So maybe they combine somehow. Here's a real one. Look at how many levels it has. Like it has level 1 and 2 are the letters, and you have 3 and 4, which are on the right here. But look at, there's a level 5 on the side of the keys. This is a thing of beauty. Look, there's the membership symbol underbar. Just think about it. Like, IBM did that. They were already a big company. At the time, this didn't sound crazy. Just I don't know, like, think about how the word was for that not to sound crazy. Say, oh, yeah, so with that floppy disk that, has my programming language, in a time where hard drive were probably not a thing yet, we're also going to ship you a keyboard. I don't know, I just love it so much. How cool would it have been to just live at that time? The code is very compact. Yeah, there's a bit of boilerplate in my code because all these types are a bit alike. So of course, like using open recursion everywhere would help, but it is not without boilerplate either. Because, or you have like pattern of like fix of blah of foo, or you just define a bunch of pattern synonyms, and to do this, well, you have to serve through the entire boilerplate again. Maybe with some template Haskell it would help. I don't know. So Unicode has a symbol for pentagram, which is fine, but it also has a symbol for an inverted pentagram, and for a right-handed interlaced pentagram and a left-handed interlaced pentagram. Actually, these are ugly country symbols. Well, that makes sense. So many things. Heavy hard exclamation mark ornament. Like this could be my prop symbol. Unicode is so fun. Such weird symbols. Anyway, we don't really need to call it a meg. For now, I'm going to call it prop. We've played enough. Oops, that is not what I meant to do. Okay. Um, 6 reduce conflicts. Ouch. How many was there for that? 6. None. You what now? Zero. And this as oh, I see. Well, maybe that was the problem. The 6 reduce conflict were all prop with prop in the same thing. Great. Okay. Right. So the thing is, I have to change x per 1 into x per 2 everywhere. No, that's tac. I don't care about tactics. What am I looking at? Where are my terms? These are, terms are here. Yeah, term 1. Still need to remember to change term 1 into term 2. And we take all this closer. Then we do all this here. We replace prop by term. There will still be references to prop, the production for prop. I should have errors now. Exactly, because concrete.prop doesn't exist anymore. So now we're going to replace this. Okay. What is this? Bri patterns.58. What does it mean? They're only identified by their index somehow. Oh yeah, by the actual dots that are on and off in the pattern. So it's very matter of factual in the Unicode standard, but I don't know what they correspond to. issue. So here we go. Interesting. Oops. Reduce conflicts. Ow. I thought I had been careful. Okay. There's also a syntax error, which may help me. 4 plus x sucks. Well, that's a syntax error that comes very, very fast. Okay. Yeah, followed by a term. So something is conflicting with something else. And we're seeing issues here. So an integer is atomic, sex atomic, ident is atomic. App takes a term return. That would be a term 1, really, I think. And returns a term 1. Still gonna have a ton of conflicts. 24. That is much better. Do I know what I'm doing? No, absolutely not. So that's the problem, I think. What we're seeing here is it used to be 2 different syntactic categories, so I didn't really have to care. But now we need to equal. I'm gonna need more priority levels, and that is becoming annoying to write. But so equal should be fairly high level. So I think I'm completely wrong about how I did all this. There's a bunch of things that should be atomic. So we're gonna do 5, 5, 5, 5, 5, 5, because nobody cares about these. App is supposed to be to bind pretty tightly, so we're going to make it a term 4 and 5. So then equal is going to be a term 3 because we want it to bind less than these. We want them to be term. Oh, we don't. Okay, we don't care too much. Okay. Well, maybe I have one too many. And this can be a term 2. This can be a term 2. Sorry, no. 4. So maybe we have that one level up. 2, 3, 3 gives me some margin. Now I have no conflict anymore, yeah? Fantastic. Wow. Didn't it look like I understood what I was doing? I know that some people have a fairly good intuition of what am I doing? Of grammars. I don't really. I'm getting used to them as well. Syntax error still. That doesn't sound right. Okay, so the syntax error is not up to date. Maybe if I here we go. Okay, so indeed these are most definitely not exhaustive. Let's start with the types. Oops. Okay. Ah, funny. Very good. So we're going to copy this here. Replace intern prop with intern term. Bang. I don't need this. All good. Now this is equal to intern term. Now I have to do extern. Extern, we have the same story that we need prop here. Okay. So for each of my types, not counting the fact that I type and R type are very much alike, and I don't really need I type and I'm wasting my time for the most part in syntax. Apart from that, like all types exist in at least 3 versions: the concrete syntax, the abstract syntax, and the view. It's a bit repetitive. But on the other hand, when we've set up these things, then everything is very generic. Well, everything, many things are very generic. We also have the, I guess the sub thing is not defined in terms of the view. So, app UV extern term blah blah blah. So this should compile. Yes, double definition, you're right. Something happened. Okay. One last one. And then we'll see if everything breaks. Whoa. That is suspicious. Well, Uh, okay. Okay, that worked. First time. First try run, yeah. It's surprising. It definitely is. So let's make a commit. Feet prepositions are now terms. Yeah. Maybe we should write something we should celebrate. What should we prove about prepositions? I'll write the induction principle. We can do that next time as well. I think we existential is not that far. We didn't need that's been done as well. I want to do some Galois connection proofs. Well, that's actually pretty cool. But since I don't have definitions yet, it's gonna take a while. So let's do something a bit smaller right now, and we can close this next time. Like do have enough material to talk about division. Hello, Komen. How are you doing today? Yeah, so I think these things we can do next time. I kind of see that we are getting onto the hard stuff, like properly handling quotients and stuff. Just finish your homework. Good for you, I suppose. It's better done than not. And doing the definitions. Definitions are interesting because I don't intend to have reduction in my system. I want the definitions to really give me some equalities that I can use as reductionable. The language in which I'm implementing this is called Haskell. It's a pure, lazy, higher order functional programming language. It's the most common programming language, but we're not seeing any Haskell on screen right now. All that we see is the syntax of the language I'm currently writing, which doesn't have a name, but might become Peppermint if it leads me somewhere. There's very much a research project at this point. I don't know what I'm doing, which is a good feeling. So anyway, let's write the fact that induction holds. Maybe we won't be able to prove this. So theorem nat and div1 is proved, yeah. So I don't know why I removed this. HTML, CSS, and JavaScript. Yeah. So of the three, it's most like JavaScript. It is strongly typed, so more like TypeScript if you've heard of this, except more so than TypeScript. Higher order is common in JavaScript, but if you've just started, you probably haven't encountered this. Okay, but sorry. I don't want to sound dismissive because I'm not, I think I should stop stream soon and go to sleep, and I'm going to try and finish something before we get there. So let me focus for a minute, and we can have a chat after. So nat end is for all capital P. What is my syntax? Okay. Of type nat to prop, as we've called it. If we have P of 0 and we have for all n P of n, I will need a type here. So let me, I will have to add syntactic sugar soon as well. So guessing the type is more than syntactic sugar. P of n, sorry, implies P of sucks n. This ought to be a fat arrow. Oops. And this as well, by the way. Then we have for all n. P of n. Okay. So our theorem will appear here, and there's already a bug. Great. I like bugs. It's a pretty big bug. What the hell have I done? So we're seeing very clearly that is supposed to be P, but the De Bruyne is incorrect. Oh, that's probably a printing bug only, because it says DB1 and that's what it's supposed to be, but it hasn't properly been. Let's have it. I expected a real bug. Okay. So extern term for all that's not how I'm printing them, am I? It's in the, okay, let's look at PP term, I think. It's not that, it's a PP goal. Oh, I'm just externing. Am I doing this? I am. Map extern prop hips. I print this, and the conclusion is extern prop conclu. So the externing is failing. Okay. So yes, it was. So if I go to extern prop, oops. Yeah, so if you've never encountered functional programming before, it's pretty different from JavaScript, because you tend to avoid mutating memory. Instead, you just name things. At first, it doesn't look very different, but it has a very different feel. And so, like, these languages put a lot of emphasis on things being immutable by default, which it just guarantees a high degree of isolation between the different parts of your code. So we like them because they help manage complexity, but they don't help writing GUIs, I suppose. So there's that. Well, that's not entirely true. sure James is boiling already. I'm sorry. So, what are we doing? Maybe substitution is wrong. I'm supposed to only substitute in closed terms, but if I'm not, then something weird is happening. This is P, db1. Oh yeah, we use that name. This is when I write underscore underscore db, what do I actually mean? I mean I so var I. And so this should be db1 should be bound because it corresponds to P. So why? There are some really cool names here that have been invented. We'll have to fix that, but it's fine. Okay, so we finally found something interesting. It is absolutely unrelated to our problem, but we found an interesting bug. That seems to happen because I'm nesting for roles, I suppose. Here I do as well, but I didn't have that problem. Not exactly sure. Oh, that's an axiom though, but yeah. We haven't printed this. Here we have a properly printed one. So I've got a for all, an imply, and then a for all. But there is db1. So I'm supposed if I do extern term here and I see a for all, I see this x, which is p in that case, and I say, oh, I'm going to substitute it. And here it was not lifted. That's what happened. Why? Why wasn't it lifted? Ah. Oops. I believe there's a little cleanup that we need to do after that. Well, oops. Yeah, this doesn't give me any error message because yeah. Okay. Okay, that was actually my fault. That was related to our problem. I thought it was. I'm disappointed. I was thinking, oh, there's a real bug. We found a bug in my code. That's something new, something that I did wrong. No, I just messed up the line somewhere. Too easy. No fun. Here we go. So yeah, it was that easy. Okay. So now it prints correctly. So what has happened here? It might have happened in other places really. Is that I have a function that says, oh, the only thing I need to care about is var, and the rest I do by gating substitution. But really, because I merged term and prop, then suddenly this case became relevant as well. but it didn't get caught by the type checker. There's a proof that, like, you know, there's a trade-off between having generic things and having the type checker telling you, oh, something's changed here. Well, anyway. Can we prove NAT end? So this is a single thing. If I do intros, we will have horrible names, I'm sure. No, they reasonable names. Now we have a natural number n and a predicate on n, and a proof that p of 0, yeah, they're reversed, but p of 0 holds, and for all n, p of n implies p of sux of n. How am I going to prove this? I'm going to prove this by induction. What's my induction syntax again? Boom, boom, boom. Induction on n is the variable. Where is it? There's starting to be a bit too much of these. The variable is n, yes. Now I should have by induction on n. Okay. I just chose a slightly more verbose route. So now we have two subproofs. This one, where we must prove that p of 0 holds, which is true by assumption. And this one, where we must prove that p of sux of n holds. And this is, and we know that p of n holds. So let's get to it. So I'm going to make two cases that are parallel. There's always a choice, which is either we use an idiom like this one, or say, okay, I'm going to just imagine there's one sub-goal and I'm going to clean up, or there's, you know, there's like one of them is some kind of side condition. So I'm going to do this one, but I'd rather treat induction as two symmetric cases. Just do the two branches. So assumption. I guess Don would. Ooh. Oh yeah. I need to write id here, I think. Better. Now I'm left with a single goal to prove, which we can prove by chaining, but I'm not sure I have any chaining tactics. This is one thing to do as well, like do a oh yeah, there's that too. To do chaining tactics. Prologue like resolution, not resolution, but proof search one. Okay. I can't see this as being likely to be very interesting. So I have a tactic for that. There was another one. Focus. So I can focus on the implication and pass it things. So focus on this, because we know. We want. I hope that will work. We want to put this into the stoop so that I can give it arguments. Oh, I need to say using, but I'm not using anything. I don't need to bring anything to scope. Wow. That is fun. Given key is not an element in the map. Isn't that fantastic? So I have to look for a bang somewhere. Not that one. No, maybe that one. No, that one. Maybe that one. This one's risky. Not that one. Not that one. So to check whether it's that one, it's fairly easy. Unfortunately, map.bang doesn't have I think it's the map blast. What did it look for? Okay, that's a type basically. Doesn't have a Haskell stack constraint, which is a pity. I forgot of, that's why it was bizarre. An error. Good, that was this one. Which gives us a bit of a chance to improve. INP is not in RENV. Curious though. So, call stack, main. Oops. 1025. Okay, so that's the bottom of the call stack. Okay, so we're type checking a refinement type. Oh, I put one here. Type check a refinement term. This one. And this one. Okay. So it seems that so what are we doing? We're doing focus, and when we're type checking focus, maybe We can just like add a Haskell stack thing here to figure out where that went wrong. They probably should all have them because they make assumption. So type check refinement type check preposition called at 12:15. Damn. So my rule of thumb is that everything that is partial, and these are very much partial, should have a Haskell stack constraint. 1274 Valtac. Yeah, actually this one should not be partial, so that's fine. So right, so we check, and that's the one. Yeah. And we're passing it the wrong environment, so check is wrong. Now this is a real bug. Aha! Let me just call these a fix up. Aha! We're gonna fix this. And removing like the type prop synonym will happen off stream because it makes really no, it doesn't matter. So let's try and see what check does. Check knows the bound variables here. View globals, view theorem. What I'm looking for is this one. Where is it used? Here. Anv. So this is the line that is supposed to add P. You know what? Where's aranv? Well, we have specific types, so we can do better. For localized. Boom. Okay, and now we're going to just look at what was produced as an aranv. Has a bunch of globals from list. So it has F as a local, type nat to nat. Y. What? This looks like this one. And there's a DB of type nat. Now I'm very confused. It is looking as though it is looking for... Like, it's even weirder than this. It is looking for P when I do focus, but it takes time to print. Oops, I may have just completely screwed up something. Right, okay. There was an error. And the error is that this shouldn't make... There was no bug. Like, it's the third time. I thought it had finally found a bug. Oh, there was one, a tiny bug that I just introduced. I think like Haskell is too good. You just can't write bug in this language. I wish. Okay, we're good. So now we have a stoop. It's here. The stoop is what I want. And so we can do a bunch of width. With n and with p of n. No. Let me check before I write this. Okay, now I should have just p of n implies p of six n. But now I need to check what width is made of. Maybe in the syntax. Width takes a term. No, use takes a term. Width takes a term. And the definition of width, if I can search, just does for all. How did I do that before? I'm sure I managed to do a couple of these. There was just no implications before. Oops. Okay, so I can't I was like, oh, maybe we can do gather connection proofs. That's a good idea. It's a great idea, except I can't even do the most basic thing because implication, I have no way to reason about it, right? Except intros. It's not too hard to do there. But I think what we can do is just extend width. For the input case. PQ. No, wait. That's nonsense. No. No, because of course there's nothing to provide. I just need to prove that it's true. Yeah, I just need a bit of chaining. I just need a tactic for that. Can call it chain. And chain equals tech.mac. Pimple PQ, all of the cases should work. It could work for negation as well. In general, whatever works for implication works for negation. So in that case, we need we have one side condition and one sub goal. Let side equal G and set to nothing, but we have to prove Q. Set concol and we want to prove P, sorry. P. And then we want the sub goal, which is G, where we just set the stoop to be Q. Then in prove G, K side and K sub. Pimples. Oops. Okay. Now we just need to add the syntax for this. And this is not T width, this is T chain. At the end, many of the tactics will be expressible in terms of the small ones. Now patterns are not exhaustive of it there. 9283. T width. Excellent. And now I can go to here and I can do chain. Normally, I should have a trivial goal and what I really want. So the first goal is P of n I need to prove, and the second goal is P of sucks n as in thing. So I can just follow this by saying done id. That should reduce me to the only goal I care, which is this one. So here I have P sucks n, P sucks n. I don't have a formulae for that. Deactivate and done. A tactic, sorry, that directly addresses this form. But we're good. We just prove that natural induction holds by natural induction. Do feat add chain tactic. This lets us prove the premise of an implication in this too. Okay. That's pretty satisfying. I don't think, oh, I see. No worries, no worries. I don't think I will remove the rests of the prop type from this file because, to be honest, nobody cares about this. And I kind of care to go to sleep. Does anyone want to chat a bit for like 15 minutes? All the while, actually, this is a word that should exist. I don't know what it should mean though. So yeah, if you want to chat about something, otherwise I'll go and start my holiday by a good night's sleep. Silent chat. Well, okay. Okay, so this is going to be all for tonight. It's a bit of achievement. We are starting actually, that was completely incidental, to build a focusing based vocabulary that would let us explain tactics. And some will become a bit easier to write, and maybe we can reduce the number of primitive tactics after a while. Should be good. Right now we have many primitive tactics. It's fine for the prototype. I'm not too worried about having a small set of tactics. Considering that one of them I will keep primitive pretty much forever is congruence closure. And congruence closure, you could make it non-primitive and make it output proof, but nah, right now I don't care. So, but like we're kind of seeing this sort of the behavior, the proper behavior coming out of this stoop approach. I'm not unhappy about this. Now, we also have propositions be term now, so we can actually quantify other propositions because we have a higher order logic. But if propositions are not a type, then you can only quantify other functions and terms, and that is much weaker. So right now the logic is pretty expressive. Not expressive enough, in my opinion, because I want to be able to quantify on types. But how exactly to do this is an open question, which I've discussed somewhere in my big challenges here. We're not going to get there quite soon. There's quite a few things to do before that will be quite interesting. So, yes, that was mostly a technical issue. There was some cool things happening and a couple of bugs that were not. So, disappointment. More seriously, so I'm going to cut stream in a minute for my schedule. So I'm going to be on holiday next week, but I don't think I'm going to cancel the next stream because it's supposed to be video games anyway, and that fits my vacation plans quite well. Besides that, I may pop up during the day on random streams. Still video gaming, almost certainly. I'm not going to do any mathematics for a week. Yeah, so these, like if I do impromptu streams, they will be like they won't be announced. Just pop up and chat. I won't be talking that much. Just randomly doing things. That's sort of the idea. If I get time or the opportunity. At any rate, yeah, that's the plan. So 2 weeks from now, we're going to resume with. I think the goal would be to be able to do these two things fairly soon, having some sort of material to start doing some a bit more serious proofs, and then we get into more difficult things. So I don't know how long it will take me to get enough material to write Galois connection proofs, which can be interesting. Like, just like proof that the two usual definitions of Galois connections are equivalent, for instance. That's very interesting. But that requires quite a bit of material, so it's without definitions, it's going to be a bit wordy. So we're going to have fun with this. Yes, as you may know, I am slated to talk at the Haskell Love Conference about some Haskell subjects. That is the last weekend of July. The weekend, it's a Friday to a Sunday. We don't have a program yet. And this is the weekend that goes over the limit between July and August. So it is possible that that particular week I don't stream, but I will share on Twitter a link to my talk in advance, so that whomever wants to watch the talk can. Like if it's public anyway. I don't exactly know how they set it up, but I'll let everybody know how this goes. Yeah, so that's in 4 or 5 weeks, 5 probably. So it's going to come up very, very soon. Right. Well, on these words, that's all for me. So I'm going to cut stream. And until then, don't forget to stay curious.